ozone in the stratosphere is decreasing, and ozone in the troposphere is increasing. So that's, and we want just the opposite. We want ozone in the stratosphere to increase and ozone near the surface of the Earth to decrease, as shown by the next slide. There is 30 miles above the ozone layer, which protects us from the ultraviolet radiation coming from the sun. An ozone molecule has this wonderful property that it absorbs UV radiation. And if we are exposed to UV radiation, it'll cause us cancer and other sorts of diseases. That layer is decreasing. The amount of ozone in the troposphere, which leads to the formation of smog and the like, is increasing. So we need to simply find a way to reverse that. This slide was the year 2000. In the year 2000, this weekly magazine, Spectator, carried an article choking on ozone, how bad is our air. And this is the triangle area in Research Triangle Park. And you can see how vividly the air pollution had gotten quite bad the year 2000. Now, there are lots of issues that go into air pollution, meteorology being a very significant component of it. But nevertheless, from 2000 to almost 10 years later, things have improved. But here is the same year, 2000, and this article suggested that Charlotte area was the 8th worst metropolitan statistical area in the country in terms of ozone pollution. Raleigh-Durham was the 11th worst ozone pollution area in the country. And you can see, if you are below the green line, you don't have a problem. If you're between the green and the yellow, you can tolerate it. But once you get into the yellow and the orange range, the pollution has become quite severe. And when you get into red, it is quite bad and or serious. And certainly when you get into this purple region, that's where Los Angeles is, okay? But nevertheless, the year 2000, this is what we had to deal with. And here is once again, you know, how we communicate with the general public. That is the newspaper, the media. You know, we give the weather on a daily basis. We now also give the air quality on a daily basis. And the way we communicate it is something like we do now for Homeland Security, the code orange and code green and code so on and so on. Similarly for air, by the way, that the Homeland Security issue for dealing with the public actually came from the way we were dealing with air pollution to begin with. So, so when we have a green code in a given region, it means the air is good. If it is yellow, it's moderate, and so on and on. Okay. What are the properties of ozone as a molecule? It has chemical properties, biological properties, and ecological properties. Chemically, it is a gas. It is soluble in water, therefore it is quite polar. It is very reactive and reacts with lots of compounds in the atmosphere to convert them into more harmful compounds in the atmosphere. However, it does have a distribution in the troposphere and stratosphere, as I explained to you a moment ago. Biologically, it produces free radicals, primarily the hydroxyl radical. And these radicals are extremely reactive once they are produced. It reacts with membranes. That's the mechanism by which ozone, once it enters the plants through the stomata, these tiny openings in the plants, it interacts with the cellular and the membrane level to kill the plants, as I will show you in some of the diagrams. Its precursors, ozone that is formed, is from both natural and anthropogenic sources, and it attenuates UVB radiation, which is good, okay? That means it absorbs UVB radiation, which is beneficial to us, the humans. Ecologically, it has very high deposition velocity. That means it will settle down very quickly, i.e. it will react with humans once we breathe and the like. And it has a relatively short half-life. It is also a greenhouse gas. It is one of those species that both absorbs UV radiation and it also absorbs infrared radiation. As an absorber of infrared radiation, it also acts as a greenhouse gas. So right there, there's a challenge facing us. Its lifetime in the atmosphere. So I got all sorts of pollutants listed here, and you can see ozone lifetime in the troposphere is moderately long-lived, which is to say it exists in the troposphere from about a few weeks to a few months. So it persists for a reasonable amount of time. Therefore, it can be transported over long distances. So how is ozone formed? Which is what I will now speak to. Ozone is formed, it is not emitted directly into the atmosphere. That means it is not a primary pollutant. What it is it is formed by chemical reactions in the atmosphere. Therefore, it is classified as a secondary pollutant. And what are those chemical reactions that go on to form ozone in the atmosphere? NOx, which is oxides of nitrogen, in combination with volatile organic compounds, which is VOCs, react in presence of sunlight to produce ozone. And I'll show you this chemical reaction simplistically in just a minute. So where does NOx come from? The largest single producer of NOx is transportation. That's where largest amount of NOx in the atmosphere comes from. The second largest producer is utilities, coal burning or fossil fuel burning plants. On the other hand, VOCs, the single largest producer of VOCs, essentially isoprene, which is a very reactive volatile organic compound, is emitted by trees and transportation. So you can quickly begin to see why Raleigh, Durham, Chapel Hill, the Triad area, and the Charlotte area would be copious amounts of ozone because I-40 and I-85 are running through these major metropolitan statistical areas, producing NOx and VOCs, which when they react in the atmosphere in presence of sunlight, you will produce ozone. So it stands to reason the only way you can bring ozone down is to somehow control either NOx or VOCs. But here lies the debate. Is majority of the VOCs in this pie is from natural sources, which is the trees. And we can hardly do anything about that. So the only thing we can realistically do to reduce ozone is to control NOx in this region from automotive exhaust. That, at the end of the day, is all we can do.